To the viewers, now we discuss the matrix representations of graph. At first, these representations have some of very important aspects, because sometimes geometrical representation of a graph has certain disadvantages, and they are only useful when number of vertices edges are relatively small, but such representation become very cumbersome and sometimes impossible if the number of vertices and edges are very large. Now we define adjacency matrix of a graph. Adjacency matrix of a graph. Let G dash be a graph having n vertices and Vg dash with a vertex set have maintained in some ordering, then adjacency of matrix of graph G dash is given by a G dash, that is adjacency of G dash, with respect to the given ordering Vg dash for both rows and columns is an n by n matrix of a dash ij. Suppose if we consider a dash ij is equal to the number of loops at v dash I if I equals to j, and the number of edges v dash I and v dash j when I not equals to j. So at first, if we take the representation, so we consider a graph having n vertices, and as well as the vertex set is considered that maintains some ordering. The adjacency of the matrix, that is a matrix of the graph G dash, is given by a G dash, and with respect to the given ordering V G dash, or both rows and columns, and it is given by a dash ij equals to number of loops at v dash j, that is if I equals to j, it means vertex sets, and if we consider the number of edges v dash I and v dash j if I not equals to j. So if we better to say to clear understandings, we consider a figure to make the clarifications and to clear the idea. At first, let us consider a figure. Suppose let G dash be the graph given below. V1 dash, V2 dash, V3 dash, V1 dash, V2 dash, V3 dash, V4 dash, V4 dash, in this way. Now it is connected with edges, incident with edges, V1 dash with V2 dash, and here also if we incident with these edges, and if we consider here like a parallel edges. Now if we consider here V4 dash, that's incident with edges also, and if we consider here, and they have a loop here and also here, that is both the loops, number of the loops. Now if we find the adjacency matrix and suppose the vertex sets, so here suppose the vertex set if we consider here like VG dash consisting of the points V1 dash, V2 dash, V3 dash and V4 dash, let's have an order V1, V2, V3, V4, then adjacency matrix is given by the following. That is, if we consider here 4, order 4, then 4 by 4 matrix. Now let's see what's happened. So at first, that means A dash G, if we consider here adjacency matrix, or if we consider better to say A G dash, in the early cases we consider A G dash, it's okay, no matter for that, and that will be given by, suppose in the notation of matrix, V1 dash, V2 dash, V3 dash and V4 dash. Here also we take the notation in the form of the matrix here, V1 dash, V2 dash, V3 dash and V4 dash. Then we consider here for V1 dash and V1 dash, that means here, that means if we take here so making this number of edges, that means if Aij is formed V1 dash, V1 dash and V1 dash, that is if I equals to j, that means, so here is the number of the loops but no loop is there if we consider the figure in the early situation, because here is V1 dash, and if they make a relation with same V1 dash, there will be no root there, we can't find any loop here, so the result will be 0. So here we put 0. Now V1 dash and V2 dash, next step for V1 dash and V2 dash. So here we find V1 dash and V2 dash. Here we find one parallel edges. There is two parallel edges, these and these. So this will be edges and this another edges. But here we consider only graphical representation. There will be no geometry here. We can't consider any geometrical idea. That's why these two edges are parallel. So we can put it as a 2. Now V1 dash and V3 dash. V1 dash and V3 dash. There will be no edges. So result will be null or 0. V1 dash and V4 dash. V1 dash and V4 dash. Here we consider only one edges, because loop is only V4 and that is a self loop. So we can only consider it as 1. V1 dash and V4 dash will be 1. Next V2 dash and V1 dash. V2 dash and V1 dash. That's also considerable if we consider here two parallel edges. So it will be 2. Now V2 dash and V2 dash. There will be no loop, because in adjacency cases for I equals to j, that means both have the same cases, same element V2 to self. So if there will be loop, then we can count, but otherwise we directly put it as 0. So result will be 0. V2 dash and V3 dash. V2 dash and V3 dash. Only one edges is there if we consider the representation. So result will be 1. Now V2 dash and V4 dash. V2 dash and V4 dash. There will be no incidents occur here. No incidence of the edges. So result will be 0. We can't find any connection. So it will be 0. Now V3 dash and V1 dash. V3 dash and V1 dash. No connection is there. So result will be 0. V3 dash and V2 dash. So there will be a 1, because only one edge we find. V3 dash, V3 dash. Here we find two loops, 1 and 1. So result will be 2. V3 dash, V4 dash. V3 dash, V4 dash. Only one edge is there. That's why result will be 1. Now V4 dash, V1 dash. Same result, one edges is there. So result will be 1. V4 dash, V2 dash. V4 dash, V2 dash. There will be no connection of incidence of any edges. So that's why result will be 0. V4 dash, V3 dash. Only one edges is there. So result will be 1. V4 dash, V4 dash. One loop is there. So result will be 1. So finally we find this adjacency matrix. In this way we can find. And so the corresponding adjacency matrix we find and given in this way. And if we find the different adjacency matrix, if we change the order, then the result will be changed. Because if we start this matrix in this way, if we take this adjacency matrix, the vertexes Vg dash, if we take like this, V2 dash, V1 dash, V4 dash and V3 dash, clearly result will change. We can find another adjacency matrix there, that will also be 4 by 4 order. Then we can arrange this matrix V2 dash, V1 dash, V4 dash, V3 dash, and here also V2 dash, V1 dash, V3 dash, V4 dash and V3 dash, taking the form of the matrix. And also consider here in matrix notation like the connection of V2 dash and V2 dash. So in this way, in the earlier stage, the same method that will be followed. V2 dash and V2 dash so there will be no connection of v2 dash and v2 dash, so that will be 0. v2 dash and v1 dash, here also v2 dash and v1 dash, two connection, two parallel edges, so result will be 2. v2 dash v4 dash, no connection is there, no incidence of edges, so result will be 0. v2 dash v3 dash, only one edges is there, result will be 1. v1 dash v2 dash, two parallel edges, result will be 2. v1 dash v1 dash, no loop is there. By the definitions of the loop at I equals to j, since there will be no loop, so result will be 0. v1 dash v4 dash, only one edges, so result will be 1. v1 dash v3 dash, result will be 0, since there will be no incidence function. v4 dash v2 dash, no connection, so result will be 0. v4 dash v1 dash, result will be 1, one edges is there. v4 dash v4 dash, v4 dash v4, since there will be a loop, because by definition of the loop, number of the loops at this, so number of the loop is 1, so result will be 1. And v4 dash v3 dash, only one edges is there, so result will be 1. v3 dash v2 dash, result will be 1. v3 dash v1 dash, no connection is there, result will be 0. v3 dash v4 dash, one edges is there, result will be 1. And v3 dash, but here we consider two loop from the pictorial representations in the figure of the graph, so result will be 2, since there is two loop. So finally we find the different adjacency matrix. So in this way we get idea how to construct and how to find the adjacency, corresponding adjacency in different adjacency matrix. And now we end our discussions. If you like this video, like it, share it, subscribe the channel. Thanks for watching.